Hi, good morning. Welcome to NodeJS classes. So today we are going to see what is NodeJS. Okay, one second. So let's see what is NodeJS. Fine. So NodeJS is nothing but a runtime environment. Just remember, very important, NodeJS is a runtime environment. We all know that JavaScript is a language and it runs on the browser. So on what basis it is running? So in browser we have something called as V8 engine. In browser we have something called as V8 engine. So whatever the JavaScript code we are writing, so that will be running on the browser. Whereas Node.js can run even on the server. How? Let's see today. Generally JavaScript runs on browser. It has something called as V8 engine. What this V8 engine will do? It converts your JavaScript code into something known as machine level understanding code. Machine level code. That's why your JavaScript code easily can run on the browser. Same way, your Node.js also internally have same engine, which is nothing but V8 engine. It converts your code into machine level code. That is the reason you can run your Node.js even on the server. Clear? JavaScript runs on the browser, whereas Node.js we can run even in the server. How? Because Node.js internally uses some engine which is called as V8 engine. That is the reason your Node.js will run even on the server. This point is clear, right? Now, we'll move something called as, let me explain this. Traditional servers like Apache servers and all. What it do? It handles a request. Let's say one thread. It's a thread, single thread language. For one request, it uses one thread, right? Let me write here. If we send one request, it uses one thread, right? What if you are having 100 requests from 100 users? Then, right, 100 threads. If we have 1000 requests, 1000 threads, then what happens to memory? It will be heavy memory usage, right? So if 100,000 requests are coming and if it is running 100,000 threads, then like memory usage will be very heavy. So Node introduced something called as event-driven architecture. Event-driven and non-blocking code. So Node introduces, in order to solve this problem, Node has given event-driven and non-blocking model. So let's see what is this non-blocking model. Let's see non-blocking model. What is this non-blocking model? So before that, let me give you a small basic example, like simple example. Just what is this blocking and what is the non-blocking? Say you have some chef in the kitchen. Okay, he is cooking some dish, and once he finished the entire dish cooking, then only he go to next order. This is what is just remember for blocking. And the same chef, what if like if he is doing chef cooking and he'll take next order, simultaneously he'll take the order and start cutting vegetables. What is happening here? He's doing simultaneous tasks without disturbing your first cooking. So what chef is doing, only cooking the first dish. After completing his, then only he'll go to take next order. Whereas here, chef is cooking your first order. Simultaneously he is taking next order also. Simultaneously he started cutting vegetables. What is happening here? Multiple tasks are going here. So this is what I can say an example for non-blocking event. And this we'll call it as blocking. Clear? So doing multiple tasks, which is called non-blocking. Let's apply the same example for file reading. Okay, let's apply for, I have something called as file. Some file consists of some lines of code. So in blocking system, if I apply blocking, what happens here in the blocking? It has to read the entire file, right? It has to read your entire file, and at final it has to start executing. So what happens here? I have file.js. So initially it has to read the entire file, and after reading entire file, if it start executing, what happens in this case? I have user or me, I have to wait a lot of time until it starts reading the entire file, and then it starts executing. Until that, user has to sit ideally in front of the system, right? Say, what if like in file.js, it starts reading one line and then it starts executing immediately that line. Simultaneously, it starts reading the second line and then it starts executing the second line also, right? Line by line, if it reads and executes, what happens here? My output will be very soon. Fine. So which is the best model, blocking or non-blocking? Yeah, right, non-blocking. So just remember this, and now we'll see your, we have some components. Okay, we have some components called as call stack, event loop, callback queue, and thread pool. Let's discuss each one by one, which are like main brain for your Node.js. So these four are the main four concepts in order to understand your Node.js. Fine. So first we'll start call stack. Before that, just let me tell you, Node.js is a single-threaded language, but internally it works as multi-threaded. What is that? It's confusing, right? It's a single-threaded, whereas internally it is multi-threaded. So in order to understand this concept, let us first understand what is call stack, event loop, callback queue, thread pool. So after completing these four concepts, you will understand the meaning of this line, what is single-threaded, and internally how it works as multi-threaded. Fine. Now let's start first with a call stack. What is call stack? Okay, whenever JavaScript runs any code, so if you are running any code of JavaScript, it uses something called as call stack. So what is stack first of all? So in order to explain this, let me write. Okay, what is stack? So how stack looks? Let me draw something like this. Okay. Imagine like you have plates. This is plate 1. This is plate 2. Plate 3. Okay. So all the plates I have arranged one above the other. Okay. So what is this? Plates I have arranged one above the other. If I have to remove the plate, what I have to do? Top plate I have to remove first and then go to second top plate. So this is what concept of last in first out, LIFO example, right? So just think like stack is nothing but arranging plates or something on one on top of the other. So the same way call stack is nothing but we have something like arranged one on top of the other. Let's explain me one example. Function greet. I have taken a simple example where I am printing console. I'm calling your greet function here. Greet function. Fine. So what I'm doing? I just ran a simple example, hello. So if we are running this code, what happens internally here? So global execution context is created. Now it will allocate some memory in the here, right, space. Now in call stack what happens? Let's jump to there directly. So JavaScript engine sees this function first. What is the function? Greet I'm calling here. So it pushes your greet. Okay, let me write here. It pushes your greet into stack. Pardon? Right here. It pushes your greet into stack. Draw some arrows. It pushes, fine. Okay. Let's say it pushes your greet into the stack. Once it goes to next line, then what is there inside greet function? Console.log of hello. So it prints console.log hello on the screen. So it prints console.log hello on the screen. Now what it do? It pops out from stack. It pops out from stack. Here initially whenever you are running your JavaScript, it checks whatever the functions are available. Now you are calling this function. Now it puts this greet function into call stack. Now it executes line by line. So here console.log hello, it executes. Then once its task is completed, it pop out from the stack and then it frees the memory. Now memory is free. Understood this? Now let me, same way I'll explain another example. Let's take another example. This example is clear, right? Now let's take function first. Right here second. Okay, I'll write another function. Here I'll print a simple console log second function. Now I'll call this first. Here I'll call the first one. So what happens here? A global execution context is created, as I said initially. Now what happens? Push first is pushed here. It pushes first. And it see the internally what it is calling? Second, right? So what happens here? Second is pushed. Last in, first out, right? Second is pushed. Now first is here. Let's write here first. What happens here now? Now it goes to line by line. So what it is calling? Console.log of second function. Am I right? So console.log of second function. So it is printed console.log second function. Console.log second function will be printed on the screen. Now what it do? It pops out from the screen. It pops out from the stack. So initially it allocates some memory. It pushes into call stack. Push into the call stack. Now it executes console.log function. Console.log. Then it pops out from the stack. Now this memory gets freed up, right? Free. memory is free now. Fine. Memory is free now. Then it goes to next first. It will see is the something we are writing. We are writing is second only. So that is what console.log already printed. Now it pops out this also from the stack. This also from the stack. Clear? Here please observe. So call stack, what it is doing? It executes one thing at a time. Is it doing multiple tasks at the same time? No, it executes one thing at a time. That means JavaScript is a single threaded language. So JavaScript is a single threaded language. But what if, like, say if thousands users are giving 1000 requests, then if it is single threaded, it has to make slowdown, right? But still we are getting the responses very fastly. How? If 1000 users are giving, yeah. So in order to explain that, let me explain an important concept which is called as asynchronous concept. Asynchronous. Okay, we'll see what is this asynchronous. Clear? So for synchronous code, I'll write an example here. Console.log start then comes to the next line, console.log middle. Okay, I'll go for next line, console.log end. I have written a simple console.log. If I run, what I'll get? Start, middle and end, right? So just correlate with the previous example what I said. Call stack executes line by line. Initially it see console.log start. It will push this in the stack. So what happens here initially? What will be pushed? Start, right? It allocates some memory in the space. It push here start. It prints console.log start. Then it pops out from the stack. Again it push next line, console.log middle, then pops out, then console.log end pops out, right? So this is the call stacks generally. It executes line by line. So we got start, middle and end. Now let me write here something called as set time out. Set time out. Okay. Set time out. I'm using arrow function here. I'll put some console.log inside timeout. I'll maintain a delay of 2 seconds. Now what it has to print? Run here. So what it will print? Start, end and inside timeout. So what happens in the background? Let us see. So initially console.log. Okay. Initially what it do? Console.log. It will be printed. It allocates start. Okay. It goes to first line. It pushes into the call stack and it prints the first line console.log start. Right. Then it pops out from the memory. Now it goes to next line, which is called as set timeout. An important point which you have to remember is JavaScript waits for nothing. JavaScript doesn't wait for nothing. Here we are maintaining some 2 seconds delay. Means JavaScript should not wait for 2 seconds. It is not a normal JavaScript function also. It is provided by Node Runtime. So Node sends this to Node API. Hey, can you read this somewhere? So what the Node does, this function, it will start reading this somewhere in the background. It will start reading this somewhere in the background. So where it will be running? Background process. Very important. Background process. Okay. In the background process, this set timeout will be running. It will not run in the call stack. So it goes to next line. Immediately it sends to the background and immediately it goes to next line. This is what console.log of end. Okay, it allocates in the call stack. Then once this execution is finished, it pops out from the stack. Let me print this console.log end. Console.log end gets printed. Now, so this, let's come back to this callback function. After 2 seconds, this callback function goes into callback queue. After 2 seconds, let me write this. This is call stack, right? No, let me write. So until here clear, right? So console.log start is, so first line it allocates some space in call stack. Once it is printed, it pops out from the stack. Then again it goes to set timeout. It start running in the background process. Then immediately JavaScript goes to next line. This is console.log end. It allocates space in call stack. Once it is executed, it pops out from the stack. Now this is freeze. Now after 2 seconds, this callback function immediately goes to something called as callback queue. Callback queue. Okay. So now from background, this callback function is running now in the callback queue. Okay, it's running now in the callback queue. From background process, it came to callback queue. Now, the main important concept will come into picture. That's what called as event loop. Event. Now, what this event loop? It acts as something like manager. So what do you do? It checks is your call stack is empty or non-empty. Okay. What this event loop will do? It checks whether your call stack is empty or not. Is it empty now? Yes, right? So start is also moved out, end is also moved out. Now nothing is there, this call stack is empty. Now what this event loop does, this event loop pushes your callback function from queue to stack. What it do? This event loop push your from callback queue to stack. What it pushes? Your set timeout function, right? Set timeout function. Now after 2 seconds, once this event loop checks, then it push from callback queue to call stack. Now it is pushed. Now it says console.log. So inside timeout. So this function, this line gets executed. Now this inside timeout will be printed on the screen. Understood? Main important concept is JavaScript doesn't wait for anything. It starts executing next line immediately whenever we are maintaining any set timeout or any other. So it moves, it send to background process and start executing immediately. And one more important concept is event loop. It acts as a manager. It manages the execution order. Clear? Now let us apply the same logic to another example, reading of the file. I'll write a simple example. Require file system. Okay. First I'll write the same line, console.log of start. I'll read the file. Let me create some dummy. inside this, let me write some console.log data. Now at the end I'll write some console.log end. So what happens in this? Right. Now console.log start will print, so it goes to first line, allocate some space in the stack, console.log start get prints this fs.read file. This is not a regular JavaScript file. So here it says to Node, hey, can you read this file for me? Yes. Now let me write again. Let's see all this again. What happens initially? It goes to first line, console.log start, allocate space here in the call stack. So once it is executed, what happens? It pops out from the call stack and gets printed here. Now it goes to next. Here what this JavaScript say, hey, can you read this file for me? Then Node gets into picture. So Node replies to JavaScript, what it say? Okay, I'll read it somewhere in the background, not in the stack. As I explained, in the background, this file is getting read. So it runs in the background. Correct. Please understand carefully. It runs in the background. So file reading goes to background. And now this system JavaScript doesn't wait for anything. Immediately it goes to next line, that is called as console.log end. It allocates some space in the call stack. It pops out after reading. So it pops out. After executing, what happens? It pops out from the stack. Again, it will be printed on the screen. So console.log end prints on the screen. Now an important concept will come into picture. That's what? Callback queue. Let me add something called as callback queue. Now after some time, what it do? This file's read file will go from background to callback queue. After some time, what it do? Go from background to callback queue. Now an important concept which I explained earlier, same event loop will come into picture. Now this event loop will check, is our call stack is empty or not? Yes, it's empty. Now what it do? It pushes the read file from callback queue to call stack. Pushes from callback queue to call stack. Clear? So now what it will print on the screen? Data. Whatever that data is there, that data gets printed. Right now I don't have any demo text file here, so I'm just writing here. So whatever the data we are maintaining, that will get printed. Now what will be printed on the screen? Start, end, and the data. Start, end, and the data. Clear, right? Now, okay, let's end this class. So this is what happens whenever we are calling the set timeout. So you clearly understood about what happens if we whenever we are running a program, how the call stack is created, how memory is allocated, and how in what execution order all the lines will be printed has been understood, right? So that's it for the today's class. So next class we are going to understand remaining things, something like as callback, event loop, in depth, and all. Okay, so please like, share, comment, and subscribe. Thank you.